Well, hello, AP Scholars. Today we're going to look at estimating proportions, but this time we're going to focus on what about the difference in two proportions, whether if we take a random sample from two different populations, or and we're going to look specifically at experiments. What if we have an experiment and we have random assignment and we want to look at the difference in proportions in the two treatment groups? So that's going to allow us to explore confidence intervals in a slightly different way. So let's go ahead and take a look at the conditions around when we are sampling without replacement. It's the same three conditions that we used with one proportion, right? It needs to be random, the 10% rule needs to be true, and then the large counts needs to be present as well. The only difference is that it needs to be true for both samples, right, and both populations. So you have to check actually both of those to do that. So let's look at this example here. You can take a moment and read through that, and I'll come back and we'll talk about it. So here we want to see if these brand names are looked at differently in these two populations. So US adults versus German adults. So first of all, let's check to make sure that the conditions are met so that we can see that. The first condition is we need to have random samples of both adults and Germans, which we do. They don't need to be the same sample size. Notice they're not here. And then notice that since we sampled, obviously 2000 is less than 10% of all US adults, and same thing for Germans. Okay. Now, large counts. Are there going to be large enough counts so that they're greater than 10? And you can see that we are going to have to do the calculation of each of those, and again, at least just set them up so that you can see that they're larger than 10. No problem there. So we'll come back to that problem in a moment. So if you think about the formula for confidence intervals, statistic plus or minus critical value times the standard deviation. For a difference of proportions, our best guess as to what the true difference is to take the difference of the samples. And in this case, if we were thinking about the standard deviation, if we knew the proportions, we could use this combination, right, that we used before when we were talking about sampling, except for the fact that we don't actually know these proportions, right? So instead, we're going to use p hat for both of them. So we're going to use the samples, and so therefore we're going to call it the standard error, right? The only difference between these two, obviously, is you're using the sample percentage instead of what the true population is, and we don't know that, so that's why we have to use that. So this is the model for what a two-sample z-interval for the difference of two population proportions will look like. Okay, so again, not too different, at least the setup is not too different from one population, except for we have to use a different statistic, because now we're taking the difference of the samples, proportions, and then the standard error for the two proportions incorporate both, right? This is adding their variances to that. Okay, so when we think about random sampling, notice that we have focused on the 10% rule, and we wanted to make sure that the random sample was taken from the population. But we want to look at, most often when we look at proportions, we're going to be talking about experiments. Because really, in experiments, the key element is there a difference in the treatments? So if we have a categorical variable, we could certainly look at that. So I want to look at this example here and give you a moment. This is also in our textbook, so you can see that. But if we look at the subjects, we looked at, in this case, there were 112 patients that had lower back pain, and they assigned to one of two treatment groups. So they gave them naproxen and Valium, and naproxen and a placebo. So Valium is a pretty strong drug when it comes to anti-inflammatory or pain relief, and then naproxen is an anti-inflammatory. So this is what they did. Now notice that they were randomly assigned to one of two treatment groups. So these people were not randomly selected from the population. They are they're volunteers, right? So one of the differences that we're going to notice is that because we're talking about an experiment, the idea of random sampling and some of the consequences don't apply here with that. So keep that in mind as we're looking at it. So the first thing we want to do is construct a 99% confidence interval for the difference in proportion of patients who reported reduced back pain of the two treatment groups. And then we'll talk about, based off that confidence interval, we could decide whether or not, if there's evidence to say whether or not Valium is actually helpful. Okay. So let's take a look at this with this interval. So if we think about the state, we want to think about, what are we doing? We're doing a 99% confidence interval for the difference in the true proportions between group 1 and group 2. Now, we could label group 1 and group 2 the treatment and placebo group, so you could do T and P, that would be fine. Or you could write it like this, where you actually define what P1 and P2 are. Now, again, one tip we have for you is just when you're thinking about defining what the parameters are, it might be it might be a good way to actually to make sure that you're talking about the true proportion of all patients of this type that do that. So we want to get away from just saying, is there a true difference in these two groups? Because we know that there's a difference between the two groups. It's not some question that we have with that. So keep that in mind, that we'll want to make sure that we have this. Now, the one difference there's two differences that when we're talking about experiments. And the first in the conditions, and the first one is that when you are looking for the random condition, you need to identify that these patients were randomly assigned. Okay, so this is not a random sample. This is random assignment. So that is a condition we check. Now, in a in an experiment like this, because you're not randomly sampling from a population, you do not need to check the 10% condition. That is not necessary because we are not sampling from a large population. The two groups that are randomly assigned, these two groups are set, so the independence is not a concern. Okay. Large counts, however, we still need to check. And we need to make sure that we have a large enough group that are saying yes and no in both groups, and in this case we do for that. So that was the plan portion, and then the do portion is, notice that we're actually going to take these two and we're going to find the difference. That's going to be our estimate. So our estimate is negative about 9%. In favor of that the second group obviously was higher than the first group. So if we take the treatment group minus the placebo group, you can see that there's a 10% difference in favor of the treatment group, right, in reduced pain. Right? And so our conclusion then would be a 99% confidence interval from negative 31% to positive 11%. So meaning it could be, the first group could be as much as a 30% reduction up to a 10% increase in pain compared to the placebo. So notice that it went from negative to positive here, and we're 99% confident that this interval is going to contain the difference in the true proportions of patients like these who would report reduced pain after taking the treatment versus the placebo, basically, is what we're looking at. And notice the term "like these" really emphasizes the fact that you're not talking about the samples, not talking about these treatments of these two groups specifically. We're talking about anyone who would be in this type of situation that might take the treatment versus the placebo. So then the second part of the question is, based off of this, can we conclude, and we have to be careful, yes, you can draw conclusions from an experiment. However, in a confidence interval, 0 is a plausible value, which means that there might not be any difference at all, right? And so what we would say is, because 0 is in the interval, we do not have convincing evidence that taking Valium along with naproxen affects pain relief like these. So a 0 means there's no change, right? And because that is a plausible value in the confidence interval, that means that there's that it's possible that there's no change in the pain reduction. Okay? All right. So just because 0 is in the interval doesn't necessarily mean that there is a difference in these two. And so you can't say, yes, the difference could be negative or positive. Just look for 0 and suggest that there's not enough evidence to conclude that is. And so we would never suggest that you believe there's a difference when 0 is in the interval. Okay? So on your calculator, we're not going to get too hung up on the calculations and trying to calculate all of it. And even the formula can get a little tricky when you're writing it out. So I'd rather have you just use the name of it. But a 2-proportion Z interval is the TI command for doing a 2-sample Z interval for the difference of population proportions. So we're going to talk a little bit about that, and I'm going to show you that a little bit in the second part of this video. So just keep that in mind as you're going through some of the problems that you'll see with the difference in proportions there. Okay? All right. So I'm going to do I'm going to do one example from your study guide to take a look at that, and hopefully we've met these 2 learning targets for today.